A fintech company, Series B, 40 engineers. They spent 6 weeks debating RAG versus fine-tuning. Architecture meetings, whiteboard sessions, vendor demos. Then they committed to fine-tuning. 18 months later, the model was outdated on day 1 of every release cycle. Retraining cost, $23,000 per run. Release cadence, every 3 weeks. Annual retraining bill, $398,000. Nobody calculated that number before the decision was made. This audit calculates it now. First, the mechanics. 2 minutes. Then the money. RAG and fine-tuning are not competing solutions to the same problem. They are solutions to fundamentally different problems. Most teams never separate the question before picking the answer. RAG, retrieval augmented generation. The base model stays untouched. When a query arrives, the system pulls relevant documents from an external knowledge store and feeds them into the model's context window alongside the query. The model reasons over that retrieved content in real time. The model does not learn anything, it reads every time. Fine-tuning is different. You take a pre-trained base model, GPT-4o, Llama 3, Claude, and you continue training it on your proprietary dataset. The model's internal weights change. The knowledge is baked in. After fine-tuning, the model responds differently. It has internalized your domain. It does not need to retrieve. It already knows. Both approaches sound compelling. Both solve real problems. The cost structures are not comparable. That is the trap. Here is the variable your team skipped. How often does your data change? That single question determines whether fine-tuning is a sound investment or a financial incinerator. Fine-tuning is a one-time knowledge transfer. The moment training completes, the model's knowledge is frozen. It knows what it knew at the training cutoff, nothing more. Your product updates, your policies change, your pricing shifts, your compliance requirements evolve. Every time that happens, the fine-tuned model is wrong. Not partially wrong, structurally wrong. And the correction is not a patch, it is a full retraining run. Let's price that out. Fine-tuning a mid-size model, GPT-4o Mini, Llama 3.8b, Mistral 7b, on a proprietary dataset of 500,000 tokens. OpenAI fine-tuning as of May 2026, $0.008 per 1,000 training tokens. 500,000 tokens, $4 for the training run itself. That number is not the problem. The problem is the infrastructure surrounding it. Data preparation, cleaning, formatting, deduplication, quality filtering of your proprietary dataset. At a mid-size company with distributed data ownership, this is a 2-week engineering task. One senior engineer, $9,600. Evaluation. You cannot deploy a fine-tuned model without running benchmark evaluations against your production test suite. Another 3 to 5 days, $3,800. Deployment infrastructure. Fine-tuned models require dedicated serving endpoints. On AWS SageMaker, a dedicated mm.g5.2x large endpoint, runs at $1.52 per hour. Always on, 24/7. $1,094 per month. You cannot share this endpoint with your base model calls. It is a fixed cost, whether the model serves 1 request per day or 1 million. First fine-tuning cycle, fully loaded, approximately $14,500. Now run that cycle every 3 weeks for a year. Data prep does not disappear. It scales down slightly. Perhaps $4,000 per cycle by the 3rd run once the pipeline matures. But evaluation, deployment, and endpoint costs remain constant. Year 1 total cost of a quarterly updating fine-tuned model at production scale, $180,000 to $230,000. Year 1 total cost at a 3-week update cadence, $380,000 to $420,000. The fintech company from the opening was not an outlier. They were running the math that their architecture proposal never modeled. Now, RAG. Same company, same use case, same query volume, RAG infrastructure has three cost components: the embedding model, the vector store, and the retrieval pipeline compute. Embedding. Convert your documents into vectors. OpenAI text-embedding-3-small at 2 cents per million tokens. A 500,000 token corpus, 1 cent to embed in full. Re-embedding when data updates, 1 cent per full refresh. Partial updates cost fractions of that. Vector store. As audited in the previous episode, PG vector on a db.m5.large RDS instance at $154 per month handles 10 million vectors at production query volumes. Retrieval compute. The cost of running context-augmented queries against your base model. For 1 million queries per day using GPT-4o at $5 per million input tokens, assuming 2,000 tokens of retrieved context per query, monthly inference cost $10,000. RAG monthly total at production scale, approximately $10,200. RAG annual total, $122,400. Against fine-tuning at a 3-week update cadence, $398,000. Delta, $275,600 per year. Same output quality for standard domain knowledge tasks. Different architectural philosophy. Radically different financial profile. But fine-tuning is not always wrong. The audit is not a verdict against fine-tuning. It is a verdict against deploying fine-tuning without modeling the retraining cadence first. Fine-tuning produces superior results in 3 specific scenarios. First, tone and format consistency at scale. If your application requires responses in a highly specific style, legal language, clinical notation, financial reporting format, fine-tuning enforces that consistency without consuming context window tokens on system prompts. At 1 million queries per day, eliminating a 500 token system prompt saves $2,500 per month in inference costs. Fine-tuning pays for itself. Second, latency critical applications. Retrieved context adds tokens to every query. More tokens means higher latency. If your P99 latency SLA is under 800 milliseconds and your retrieval pipeline adds 200 to 400 milliseconds of overhead, fine-tuning removes that overhead entirely. The performance case is real. Third, genuinely static knowledge domains. If your domain knowledge changes less than once per quarter, medical coding standards, historical legal precedents, fixed regulatory frameworks, the retraining cadence cost is manageable and the quality improvement is measurable. Outside these 3 scenarios, fine-tuning is retraining cost without structural advantage. Decision matrix. No ambiguity. Data updates more frequently than once per quarter. RAG. The retraining economics do not close. Fine-tuning will cost you more than it saves within 12 months. Latency SLA under 800 milliseconds, with retrieval adding material overhead, benchmark both architectures. Fine-tuning may justify its cost on performance grounds alone. Tone and format consistency is mission critical at query volumes above 500,000 per day. Model the system prompt elimination savings. Fine-tuning may be net positive within 6 months. Static knowledge, less than quarterly updates, no latency constraint. Either architecture is defensible. Fine-tuning produces marginally better quality. RAG produces lower operational risk. The data mandates RAG unless quality benchmarks show a material gap. The fintech company migrated to RAG 11 months after the original fine-tuning decision. Migration took 6 weeks. Annual infrastructure costs dropped from $398,000 to $122,400. The $275,600 delta now funds 3 additional engineering hires. The original fine-tuning decision was not wrong because fine-tuning is a bad technology. It was wrong because nobody asked how often the data changes before selecting the architecture. That question takes 10 minutes to answer. The retraining invoice takes 3 years to retire. All pricing figures reflect official vendor documentation as of May 2026. Cloud pricing and model API rates update frequently. Verify current figures before any architecture commitment. Subscribe to the Stack Anatomy. We'll see you in the next dissection.